where we can store our stuff. Okay, so store our messages. Now this helps us in storing messages, and the biggest benefit of using a queue storage is the fact that in the queue storage, suppose I have a lot of messages that I want to store, right? In the queue storage, the best thing that will happen is I can store all the messages and I will get the messages later on when I need it. Okay, now let's go to Azure features, the features that we can have. Firstly, we have availability, right? As the name suggests, the word availability literally means that something will be available to me for a long time. Suppose I have a web server. OK, I have this web server and I'm going to store something in this web server for a long time. Right. I want people to access it. But now what happens? For some reason, my data center goes down. Right. Now there will be a huge problem if my data center goes down and I am not able to recover that. And my people who want to access the things that are in that data center are not able to access it. So what I will do, I will use availability, high availability services to actually give me access to more data centers, right? So suppose I have two available servers. Suppose one goes down. What will happen? The second one will come up. The second one will start doing this work. So basically, this will make my system highly available. OK. So this is the basic thing of availability. Now let's see scalability. Now in simple words, let's draw a scale, right? This is a scale. 1, 2, 3, 4, 5, 6 we can have. OK. So suppose what happens? I have a virtual machine. Normally, I feel like my virtual machine only needs one core. These are the number of cores I can have. Number of cores. I only need one core. OK. But for some reason in the holiday season, I feel like my virtual machine needs more cores. What I'm going to do? I'm going to take this number of cores and scale it to 5. If my virtual machine needs more than the required, then I can just scale the number of cores that it has, or maybe even scale the number of virtual machines I can have. Same thing. So that is the main concept of scalability. After my thing ends, after my shift ends, where I want to see that, OK, my virtual machines can be rolled back to 1, I can just do that. That is the thing of using scalability. OK. Now let's see agility. What does the word agile mean? It literally means speed, right? Agile means speed. Now agility helps us to, agility basically means that something on the cloud is very fast. As I told you, provisioning and deprovisioning systems on the cloud is very fast. Now, what does that mean? Suppose I have a virtual machine now. I don't want the virtual machine in the next minute. I don't want it. I can do that because I have a very agile system, right? It is very fast. OK. In the same way, suppose I want let's take the example of scalability. Suppose I want to scale my system from 1 core to 5 cores in 1 minute. I can do that because I have an agile system. Agility does not mean the system being fast, but changes to the system or making or deploying something is very fast. That is the main thing about agility. OK. Now with this, we'll come to fault tolerance, right? What does a fault mean? Some sort of an error, right? A fault means some sort of an error. OK. Suppose I'm drawing a system here, random system, not even straight. Right. So machine 1, this is depends on machine 2. This depends on machine 3. This depends on machine 4. This depends on machine 5. This depends on machine 6. Suppose at any point, one of my machines doesn't work. What will happen? These three machines will continue working. These two machines will not work. These will continue. This will not work. But when I have fault tolerance, one moment. When I have fault tolerance, what will happen? These machines will automatically detect the fact that, OK, one of these machines is not working. No problem. We'll just go back to this. So suppose you have a web server, right? I'm giving you the example where you can use this fault tolerance feature. Suppose you have a web server where, for example, the web server has some sort of a workflow that is going on. You give names, the names are recorded, the names are stored in a database, etc., etc. But for some reason, the database stops working. Where will the name store? You can set up a fault tolerant system where if the one database stops working, then there are 5 other databases to choose from. OK, that is the thing about fault tolerance. It's a big feature when you come to cloud computing and Azure, is that in fault tolerance, you can basically live tension free. That OK, I have deployed this is working, and my fault tolerance system will kick in anytime there is a problem. Now, fault tolerance doesn't mean that once something stops working, it will not tell you, hey, this is stopped working. Don't worry, we'll take care of it. It is kind of that, but it will also tell you that, hey, this has stopped working. You should take care of it. OK. Now we look at elasticity, right? Now I want you to imagine an elastic rubber band. This is the normal size of the elastic rubber band. Suppose I pull it, it becomes in this size. And I again let it go. It will again return to its original size. This is basically the thing that we are looking into elasticity. What happens is, suppose I have a compute engine of 1 core. This elasticity is kind of connected with scalability and availability. OK. So I have a system which is made up of 1 core. In the let's say in the holiday season, there are a lot of people who are free. They have a lot of things to do. So what they do, they start visiting your website, or they start doing whatever you have deployed. Now what happens? Your system will automatically detect that, OK, there is an increase in the number of traffic. I need more people to come. I need more people to come here, right? I need more people to accommodate. So what I'll do, this will automatically scale to 5, right? 5 or whatever value you set it. This will automatically scale it. Now everybody is coming here, no problems. This will not go down. This server, whatever happens, the server will not go down. And after scaling this to 5, suppose the holiday season ends. There are no more holidays. What will happen? This will scale back to 1. So basically, it's an elastic system. What happens? This elasticity feature will help the system automatically improvise to the situation, right? So you can see all these features are based upon each other, right? So if I start from the middle one, agility, let's start from agility. What agility helps? Agility helps all these things happening very fast. OK. In availability, what does availability mean? It means my service will be available, right? Scalability helps in availability because it increases the number of cores. Agility, I can increase my number of cores in a very fast manner. Fault tolerance, I will increase the stability of the system, right? So more availability. Elasticity, I'm increasing the cores automatically and decreasing also. So it is basically a part of availability. When I come to scalability, you can see I have agility, fault tolerance, elasticity. Why? Because scalability helps in availability, and a scalable system should be fast. A scalable system might have fault tolerance, right? And a scalable system has to have elasticity. Not has to have, but it usually has. You might ask, where is elasticity used? Firstly, in power consumption. It reduces the power consumption and increases the power consumption as we need it. OK. Secondly, it also helps in the number of the cost. OK. Suppose I'm using 1 core here, I will use 5 cores. 5 cores will cost more. So it will automatically go down to 1 core whenever needed. So cost is also taken care of. With this, I'll show you how to set up your account. Give me one moment. So I want you to go to portal.azure.com. You might have multiple accounts or you might not have an account. If you don't have an account, just select this, use another account or maybe make an account. I am going to sign in for now. OK, this is not the page that you're going to see. This is the page that you're going to see. Normally, you might not have anything here in this region. You will have some things written here and stuff, but this is the main page that you want to see. OK, if you want to check which account that you're in, you can see these are the accounts that you have. OK, now if you're a student, then you should go to education. Now I have education here, but you might not have. You can just search education, go to education, and this will be the overview section. Now I've already set up my student account, so I cannot set it up again. But if you see the student account it will tell you that are you a student? If you want to set up your student account, there will be a blue button right here, almost in the middle right region, right? So it will tell you that, OK, you're a student. So you want to click here and it will ask for a few things, very important. The few things will include your student ID, your college name, and some basic stuff, right? Now, some examples that I would like to show you is that you can see I've used Azure for maybe 4 or 5 months, and I've only used about $2, I think. So you can understand how pay-as-you-go model works. I'm only paying for what I need. OK, so you can see I've only spent $2.2. If you follow my red mouse cursor, you can see I've spent only $2.2 in this time. The Azure student offer will give you basically $100 of free credit. So you can understand it will last for a long time. Now, if you are not a student, then how to get your Azure? You can go to education.github.com basically. And here you will see that in education.github.com, firstly, if you don't have a GitHub account, I seriously suggest you to make a GitHub account. And with that, you can just select here, get the student pack. Right. And in the student pack, you will see you have Microsoft Azure. This will give you free access to more than 25 Azure cloud services. And also it will give you $100 of Azure in credit. OK, there are a lot more offers that you can have. You can just see how much I'm scrolling through with the student developer pack. So I seriously suggest you set up your student developer pack with GitHub. And once you set it up, you can just connect it to your Azure and then we can go on. Now, if anyone has a problem setting up their account, you can just contact me and I'll tell you how. So with that being said, now let's see. So we have set up the for students with student mail and without student mail. Now, if you're a non-student, OK, if you're a non-student, what to do? If you're a non-student, then you have to go to subscriptions. And here I already have Azure for students, but this will not be available for you. You have to go to add, and then this will check multiple things for you. What is the best offer and thing? What is the best for your region? What is the best for your use case? And then it will give you a free options. See, as you can see, you have pay as you go model, as I told you. So pay as you go model means no upfront costs and no long-term commitment. You only pay for the resources that you use. Very important. OK, so with that being said, we are all good to go. Suppose I think you have set up your account. So let's see how to do serverless computing. Now in serverless computing, there are two main things. Azure Functions. If you remember, I mentioned Azure Functions back in the compute slide. Let's see if I can find that here. So you can see in the compute services in Azure services, we have Azure Functions. OK, this one. So what is Azure Functions? We have Azure Functions and we have Azure Logic Apps. Now let's talk about both of these in the next slide. Now, firstly, what is serverless computing? Very honestly, what does a server mean? A server means a place where something runs, right? It's serving something. What does less mean? Without. So without a server, I'm going to do my computing. And basically this means the same. So as you can see with serverless computing applications, the cloud service provider will automatically provision, scale and manage my infrastructure required to run my code. OK, so what will it do? It will provision, it will scale, and it will also manage the infrastructure. I don't have to care about anything, any of these. I just have to care about running my code properly. That is the important part in serverless computing, right? So let's see the types of serverless computing we can have. Firstly, we have Azure Logic Apps. Now, what are Logic Apps? I have made this list in a very simple way because Logic Apps and Azure Functions, these two are very common questions in the Azer 900 exam. If you want to get the Azer 900 exam, ace the Azer 900 exam, these are common questions that might come. Remember, it helps us in two things, automation and orchestration. Now, you might think these two words are closely related, and it is true. These two words are closely related. Automation means automating something so that you don't have to involve in it later. Orchestration means connecting some things and making it automated, not really automated, but maybe triggered from one or the other. It's almost like a workflow. OK, when everything works together in harmony, when something gets triggered, that thing triggers the other and that thing triggers the other. This means orchestration, right? So Logic Apps helps us in the automation and orchestration of what? Tasks, any task that I want. It can help me in doing that. Business processes. Now, business processes are large things. We might need data. We might need to store data. Now we can automate that and also orchestrate that. OK. And workflows. As I said, I'll tell you about workflows later. What are workflows and how workflows work? So it helps us in the automation and the orchestration of tasks, business procedures, and workflows. Very important. Now, you might ask when we are using Logic Apps. I might use normal virtual machines only. Why I'm using Logic Apps? I am usually using this when I need to integrate something, right? I want to integrate something into something. I'm integrating either apps, I'm integrating data, I'm integrating systems, or I'm integrating services inside services. OK, so these are the main use cases of Azure Logic Apps. Now let's compare this to Azure Functions. Now, what was the main idea of serverless computing? Serverless computing means the cloud service provider will automatically provision, scale, and manage the infrastructure, right? But here in functions, the thing is the service, the code will run on the service. It will not run on the platform or the infrastructure. How amazing. So the code runs on my service and it does not depend anyhow on the platform, that is the OS or the application gateway that I'm using or the infrastructure that it is hosted in. If required, my serverless solution of Azure Functions will automatically make or create an infrastructure based on an event. As I said, in a workflow, you have triggers, right? What are triggers? Triggers are things that maybe tell, OK, this thing is complete or this thing is happening. You want to do this, right? Suppose task 1 is complete. Now you go to task 2, right? There will be a trigger that does this. It will see that, OK, task 1 complete. Now go to task 2. So this functions, it has a trigger that it will see, OK, this event will be the place where you will see that, OK, my task 1 is complete or my functions requires this type of infrastructure. So create this type of infrastructure, right? So this is the main idea of serverless computing. OK. Now, one big example is in Logic Apps, we don't really need code. OK, it's codeless. And in functions, we need to write code, right? So in logic apps, it doesn't matter if I know how to code, I don't know how to code, doesn't matter. All I need is the task that I'm going to do, and I'm going to do that easily. In functions, I need to code, right? I need to write some code. I need to see how my application will work, etc., etc. And that will lead me to see how my things are working. Okay. With this, let's move on to regions and availability zones. This is another very big place which comes in the AZ 900 exam. And I seriously think that this place is one of the most important things when you come to things like availability, right? You remember availability? We talked about availability, right? Where did it go? Here, availability. Regions, availability zones, and region pairs. These are important things when it comes to availability. Right. Now, what are regions? Suppose I have two data centers, right? This is data center one. This is data center two. These two are very close to each other, very close. Or maybe there are even three or maybe four, right? These are very close to each other. This will make up a region. This whole thing is a region. OK, this is one region. OK, as I said, these provide flexibility. Why? I can use any of the data centers I need. These can help us scale because maybe I need 50 cores. I need 50 virtual machines, right? Not 50 cores, 50 virtual machines. What will happen? In my first data center, I might have only 5 cores available, 5 cores left. No problem. I'll take the rest of the virtual machines from the data center too. No problem. These are in close proximity. So the latency is also very less. Now it also preserves data residency with a comprehensive compliance offering. Don't worry about compliance offering. Word, it basically means that I am complying with something. Data residency. What does that mean? Suppose I'm storing data here. Suppose this data center goes down. My data is also here. I can store the data here. Doesn't matter. So I'm preserving my data, right? That is data residency. So these are the main reasons why we use regions. OK, so as you can see, these helps in high availability. Now these are some examples or dots where the regions are placed. As you can see, we have a lot in America. We have a lot in Europe. We have some in the Southeast Asia region. We also have some here and Australia. OK, so we have a lot of data centers. As I said, we have around 54 data centers around the globe. So it's a lot. Yeah. With this being said, let's come to region pairs. What are region pairs? Now, suppose I have region one. Now, as you remember, regions have many data centers among them. Suppose I have region one and region two. OK. If they have at least 300 miles, I don't know what is that in kilometers, but if they have at least 300 miles of separation between them, then I can set up a region pair among them. Now you might ask, why are we using a region pair? OK, I'll give you an example. So these are some features, but I cannot really tell this to you until I explain. Right, so let's see. Let's rub this out and let's see why we use region pairs. Let's get my pen. Suppose I have one region. OK, this is region one. There are multiple data centers that are related in close proximity with each other. I told that to you in the last slide. Regions are made up of one or more data centers and proximity. Now, suppose all the internet to that region stops. Not only will one data center fail, all the data centers will stop failing. OK, that is a problem. Because if all my data centers stop failing, then if I have set up my system on one region pair alone, then that region pair will basically fail. I will not have my system and I will not have my applications running. So what I do, I set up a region pair. As I said, these have 300 miles of separation between them. So it is very unlikely these have at least 3 miles of separations between them, not 300. This is R2, sorry. So what happens is, suppose this goes down. It is highly unlikely that internet here will also go down. Highly unlikely. The internet here might stay, right? So my service will keep on running here. That is the thing. Now you might ask me, suppose they have 300 miles of separation. So they will not have easy latency. No, definitely not. They will have considerable latency. But the thing is, suppose I am storing one file here. OK, that file will automatically get stored here. It will copy that file here. Right. So you can see it has automatic replication for some services. For most services, actually, it has automatic replication. OK, so if I set up something here and I want to copy it to some other place, I just set up a region pair and that thing will automatically be copied here. We have prioritized region recovery. What does that mean? My system will check if this region is better or this region is better, which will run my deployment better. So it will automatically choose, OK, this deployment is doing better, so I'll choose this one. Or if this deployment is doing better, I'll choose this one. And of course, updates are rolled out sequentially to minimize the downtime. OK, so both of these are updated so that the downtime between switching to this are very less. OK, these are some region pairs we can have. Let me just rub out my drawings so that you can see properly. So we have North Central US with South Central US. You see, these are kind of both are in Central US, but this is just in North and this is in South. We have East US, West US. Just like that, we have Southeast Asia, we have East Asia. We have Germany Central and Northeast, Germany Northeast. We have UK West, UK South. So you can see these are connected in some region, some sort. So we have India South and India Central. So they might be separated by a long distance, but these things will help us. These things are basically the reason why we use our region pairs. Now let's come to availability zones. Very important topic. Now, what is an availability zone? Basically, an availability zone protects us against downtime due to a data center failure. Now, this is a data center, multiple data centers set up a region, right? Now, what if I don't make them into a region? I just use separate data centers, right? And these are connected with fiber optic. OK, these are totally independent in terms of networking, in terms of cooling, in terms of everything. These are independent, right? So if I set this up, then you can only understand if one goes down, then it will not affect the rest of the three. So this is kind of the acting like fault tolerance. I told you about fault tolerance back here. Fault tolerance. What does fault tolerance happen? Availability. What is the name of the thing that we are studying? Availability zones. OK. So as you can see, these are physically separate data centers within the same region. They are under the same region, but they're physically separated. Each data center is equipped with independent power, cooling, and networking. So this is very important. So these are the three things that fail. So if the power fails for some reason, the cooling fails for some reason, or the networking fails for some reason in any one of the data centers, it will not affect how it is working in the other data centers, right? So as you can see, these are connected through private fiber optic networks so that we can reduce the latency. Because even though these are physically separate, there might be a high latency. So we consider using fiber optic networks so that we can have the least latency possible. Now, as you can see, these are some availability zones. These are the individual data centers that are working. These blue ones are the ones that might not be working. So as you can see, these are connected with this. connected with this, connected with this. So after studying all this, let's take the example of a website, right? I love the example of a website. Suppose you have set up a website, okay? And what happens? For some reason, the place where you have hosted the website on goes down. Now what will happen? Your website will go down, right? But if you have set up a region pair, that thing will stay up. If you have set up availability zone, that thing will stay up. So you can only understand region pairs and availability zones. These help us in gaining the availability of any service or anything that I've hosted on the cloud. So this is one thing that you might think that, okay, if I'm hosting something on the cloud, then this thing might not be available. Anything can happen and I might not be sure of it. But no, if I'm doing that, then if I'm taking these precautions, then it is pretty much impossible, not impossible, but highly improbable for my service to go down. Okay, I will tell you about service level agreement in one of the later slides, how it works. Okay, so with this, we come to resource locks. Okay, very interesting. This is also a very burning question in the Azer 900 exam. If you want to know, if you want to ace the Azer 900, then you want to study the resource lock system, how it works and why it works. So resource manager locks, aka resource locks. What is it? Imagine you have an enterprise, right? You are the CEO of an enterprise. Okay, you're using Azure for all your services that you require, databases, storage, compute engines, whatever. For some reason, one of your employees, he or she tries to delete something that is very important to you or very important to your system. That might be a big problem. Then what to do? We will use resource locks. In resource locks, what will happen when that person tries to delete something, right? When that person tries to delete something, this lock will prevent that person from deleting it. Only the person who made the lock, only the person who made the lock will be allowed to delete the thing, right? So as you can read, these provide us a way for administrators, very important word, administrators, only admins can do this, or people who are authorized to make resource locks. They can do this. To lock down Azure resources to prevent deletion or changing of a resource. Now, you might think that I don't know what a resource is, right? I'll show you what a resource is. Okay, so this is the Azure platform that we can have. See, recent resources. As you can see, these are all the resources that I have for now. Okay, so if I go and delete any one of them, that will create a problem, right? But with resource locks, I can search just locks. Okay, so see, it's now showing me customer log box, but there are resource log. I'm not really sure if it's enabled for me, but no problem. So you just need to know the fact that resource locks give us a way to lock down resources when somebody tries to delete or change a resource. Okay. This part is kind of important. These locks sit outside the role-based access controls. Now, what is role-based access control? Let me explain RBAC to you. Now, suppose I have three departments in my system, in my enterprise, right? Suppose you're the CEO and there is a development team, there is a management team, and there is a marketing team. Okay, these three teams. My development team will get to access the things like the database and maybe things like the app services and stuff like that. My marketing team will get access of these files that are stored. Suppose the marketing stuff. Oh, this is actually management, but still, whatever. The marketing team will get to access the storage for whatever reasons they want. Right. So what can I have? I can have role-based access controls. I will not let my management team go and see the development team's stuff. I will not let my management teams go and see the marketing team stuff. Same way, I will not let my development team go and see my management team stuff. That's why I will set up roles. Okay. I will set up roles. These roles will help me give access to some resource based upon what I've said that. Okay, so suppose some new employee comes into your in your company and you want that person to be in the development team. You want DevOps, right? So what will you do? You will just tag him with the DevOps. Okay. Once you do that, you can just all the access that the DevOps team gets will automatically be given to him. So you can only understand how easy it is to set up a new employee in the DevOps team, right? So as you can see, these will place a restriction on all the resource for all users, right? So in the security system, suppose I have RBAC. Sorry for my bad handwriting. RBAC just, and above this we have the resource lock, right? So everyone inside the system will do whatever they want, but they cannot delete because there is a lock on the outside. This lock can be only be unlocked by who? The administrators or the person who built the lock. Okay. So this was basically what I wanted to say about locks. I also want to tell you about resource tags. Resource tags are basically things that are helping us tag resources. Like suppose I want a file of mine to be tagged as important. So I tag that resource. What will it do? It will help me search the file for later use. It will also help me put the file in some sort of a safe box or in some sort of an access control. Okay. Same thing that I told you about employees, that once I give an employee, I will tag that employee as a developer. Same thing for resources, right? I will tag that resource as resource for the development team. So it will all automatically, the development team will automatically have access to it. Yes, we come to Azure IoT. Now, if you don't know, IoT stands for Internet of Things, the fashion of joining different things together to make something bigger. That is IoT. Now, this is also a very burning question in AZ 900. Basically, I've made the PPT for that. Now, what is Azure IoT? Azure IoT is a fully managed global IoT SaaS solution. Now let's go back and see what is SaaS. I think you guys remember, but still, what is SaaS? Software as a service. Okay. So the software as a solution helps us what? It helps us to connect to cloud-based apps over the internet. But what is special in Azure IoT is in this case, we are not just connecting to the cloud-based apps. We are also connecting to devices. Okay. What does it help in? All the IoT devices that I can have. Imagine IoT is a device, right? What will it help me to do? It will help me to connect to all of those devices. It will help me monitor all of those devices and it will help me manage those devices. Suppose I have 5 devices. 5 devices just set up. Okay. Random devices. So what I will do with IoT Central, I will connect to all of these in one place. Right. I will monitor each. So I can see what data this is giving, what data this is giving, this, and this. And it also helps me manage. So what does that mean? Suppose at some point I feel like this device is not working properly. I don't want to use this device. Just cross it out. Don't use it because I'm using IoT Central to help me manage the IoT stuff that I have. Okay. With this, we'll come to the IoT Hub, right? These names, the IoT Central and the IoT Hub, is a bit confusing, right? The Central and the Hub, it's a bit confusing, but don't worry, this Central and the Hub means the same thing. Not really the same thing, but the hub is basically a place where you can manage services, and the central is a place where you can connect, monitor, and manage. Okay, just checking if you guys are still watching. Okay, no problem. Okay, so very sorry for that. So what is the main difference of IoT Hub? You might ask. Now, what is IoT Hub? You first understand. What was IoT Central? It helped us to connect, monitor, and manage. But what is IoT Hub? It is a central messaging system. It is a messaging hub for bidirectional communication. These are very important keywords. You can mark it down if you want. These are central messaging hub for bidirectional communication between IoT applications and the devices. Okay. So normally in IoT Central, I just connected, monitor, and managed. But these IoT systems cannot really talk with each other if they want. So what if I want to set up a workflow with the IoT system? I cannot have that. But with the IoT hub, what happens? This will act as central messaging hub for bidirectional communication between the IoT applications. How cool, right? So what will it help me in? My IoT devices can talk among each other. Okay. That is the main point. We'll come to Aziosphere. Now, even though the name doesn't contain the word IoT, it also falls under Azure IoT. Azure Sphere is basically a place. It is almost like the IoT hub, but the main difference from the IoT hub is that this is secured. Okay, this is secured. This is a high-level application platform. Okay, so as you can see, this is a high-level application platform which is secured. In IoT Hub, you didn't find the word security anywhere. You just saw that it is a central messaging hub for bidirectional communication between IoT applications and devices. Azure Sphere, the main thing is it is secured. High-level application platform with built-in communication and security features for the internet connected devices. So suppose I have 2 or maybe 3 devices. Let me just draw 3 devices. This is based on this is based on this, and this is based on this. These 3 are interconnected. OK, so I am securing all of that with Azure Sphere. OK, these connections between them are secured. No one in between can read these or understand these, right? What does Azure Sphere have? It has built-in communication and security features. For what? For internet connected devices, for IoT internet connected devices. OK, so that is the main feature of Azure IoT Hub. Sorry, Azure Sphere. OK, with this we come to AI and ML in Azure. This is something you guys have been waiting for a long time, I know. Now let's see how can we use AI and ML in Azure. So firstly, we have the Azure ML Studio. This is just an amazing thing. I cannot explain it in words. This thing itself, this ML Studio itself, it can develop, train, and deploy machine learning models. OK, so basically you can do everything with ML. It can develop the ML model, it can train the ML model, it can also deploy the ML model. OK, so suppose I have a data set, but I don't know how to code. OK, I don't know how to write Python. I don't know how to write Jupyter Notebook. So how will I make my ML model? Well, no worries. Azure has got AutoML for you. This is one of the features I discovered very recently, but AutoML is a feature that basically takes in data sets. OK, it takes in data sets and you tell it what to predict. You tell it what you're going to predict and it will automatically predict it. OK, it will look after everything that you want to see. It will look after the facts that OK, so these are the parameters that matter. These are the parameters that I want to have. OK, you have to predict this. So it will just predict it. And don't worry, this AutoML feature will go through every type of equation and systems that you can have. It will go through random forest, it will go through XGBoost, it will go through decision tree, everything. And it will find the best algorithm for you. OK, all you have to do is give it the data set and wait. You don't have to code, you just have to set it up and go. With this, I come to cognitive services. Now, what is cognition? You guys might have heard about the word recognition. What does that mean? Recognizing something. Anytime you hear this word cognitive, it means something to do with sensory devices, the devices that are on our face. Okay. So cognitive services, what will it help us in? It will help us to see, hear, speak, understand, and interpret. Okay. See, just like our eyes, hear, just like our ears, speak, just like our mouth, understand like our brain, and interpret also like our brain. So cognitive services is basically stuff that helps us in doing things that are visual, maybe audible, maybe it needs to understand something, maybe it needs to hear something and then understand it. Okay. So I want to talk about two main things here. These two are very important when it comes to the AZ900. This question I see coming in every AZ900 exam almost. So there are two things, custom vision and computer vision. Okay. Custom vision means I will give it my own data set. Okay. My own data set. This data set will be mine. This is not a P, it's a D. This data set will be mine. Okay. These files that I'm giving it will be mine. Right. But with computer vision, what will happen? I'll have to choose from the existing data set. So I don't know if you know, but Azure has a lot of existing data sets, right? And the computer vision basically helps us in choosing of one of those existing data sets and then make our predictions. So what are one of the main things that we can have? So let's take into consideration the object detection. The object detection, right? What does that help us in? It will help us in taking a picture, okay, taking a picture and detecting objects in it. Suppose I'm taking a picture of a car. My computer vision will go through all of its car data sets and train itself to give me the bounding box. It is very important. This bounding box it will give me that will show that, okay, this is a car. Okay. In the custom vision, I might do it for devices that might do it for objects that are not pre-trained. Suppose I want to detect a pair of spectacles. Suppose I want to detect sunglasses. Suppose I want to detect a mobile phone. I don't think these data sets are already existing in the Azure database. So what you can do, you can give your own files. You can tell, OK, see, this is a picture of mobile phone. This is a picture of my sunglasses. You can use any of these to predict that this is a sunglass or this is a mobile phone, right? So that is with custom vision. That is why it's named as custom. With this, let's come to the Azure Bot Service. Now, what is a bot? Short form for robot. Now, the bot service, as it says, it helps us to develop. What does it help us in developing? Intelligent enterprise grade bots. So if I'm making an enterprise, suppose I've made a website, right? I've made a health website and there I want to see if my health website will give me proper health recommendations. Suppose it'll tell me that eat healthy, or maybe you're having this problem. Try this, try doing this, or maybe contact your doctor, right? So it will give us intelligent enterprise grade bots, right? It usually used in enterprises, as you can see. They can be used in web apps, maybe as help bots for navigation, maybe awareness bots, as I gave you the example, also as health bots, etc. It can be used for multiple things. Now, you might ask me, how is it intelligent? OK, I can also do this with Python with a simple if else statement. Suppose someone writes me hi, I'll return hello, how are you doing to him. But what Azure Bot Service does, it will understand that I have written hi, I'm greeting it something. OK, so instead of hi, if someone writes something like hey, the Azure Bot Service will intelligently understand that, OK, this person is greeting me. It is showing me a token of greeting. OK, so it will return whatever you want it to. Suppose it will say, hey, how are you doing? What can I help you with? OK, so Azure Bot Service helps us in that. With this, let's deploy our web app. So same place, let's go to portal.azure.com. I hope you guys are listening. So let's go to portal.azure.com. Where here, firstly, I want you to open your GitHub, right? Let's open your GitHub. And in your GitHub, you must have a repository that has your web app. OK, now this is my web app that I've made. Doesn't matter if you're making a different web app, but there are few things that I want you to just take care into consideration. You need to have a requirements.txt file. OK, now let's open the requirements.txt file. What are we having? We are having different words with the version numbers. What are these words? These words are basically packages that I'm going to need. OK, these are packages. Matplotlib is a package, Pandas is a package, Seaborn is a package, Flask is a package, NumPy is a package, SciPy is a package, Scikit-learn is a package. OK, now it is very important to have something like that because Azure will automatically read this. It will read this and it will see, OK, so these are the requirements that my user needs. I will automatically take care of that. OK, with this, let's make our web app. Now, you might not be having anything here. Just press create a resource. With that, press on web app. OK, now you can select your subscription. Of course, I'm using Azure for Students. Now you can make a resource group on your own. It can be anything. I have one ready. It is named as GitHub Apps since I'm using my GitHub. OK, now you need to give a web app name. Now remember, one main thing about setting the web app name is the fact that the web app name must be unique. OK, it cannot be something like test. You can see when I set it up like test, it is telling me the app name is not available. Why? Somewhere around the world, someone is already using that. OK, I cannot use that. Suppose then you're testing 1, 2, 3. Let's give it this. OK, even this is not available. So maybe let's name this as Azure Funda. OK, not Fanda, Funda. OK, even this is not available. Mentals. How about this? How about this? OK, this is available. So you can see you have to make a very unique name for your web app because since this is going to be deployed on the web, two websites with the same name cannot exist. OK, so after doing this, you might see I'm already going to run my web app now because it's going to take a bit of time to deploy. So as you can see, my web app is made in Python. You can see this is app.py. OK, app.py. It's made in Python. And you can make a very simple web app. As you can see, this is all, it's basically just 45 lines of code. OK, so I'm selecting my runtime stack as Python. Now, where did Python go? So I want to notice something that for everything, every stack that we have, I mentioned that we have a lot of stacks on Azure, right? Every stack that we have, you can basically see that I have multiple versions. So it doesn't matter if you made the app on an older version, it is automatically going to detect that. But it is better that you select the one you have. For region, I'm just going to select Central US for now. I am running this on a Linux plan. OK, you can run it in a Windows if you want. I have already a name set up for GitHub apps. I usually suggest to keep the same resource group name for the app service plan. OK, so this will help you in kind of relating what you deployed and how you deployed it. OK, now I selected the free version. I also suggest you select the free version because this free version is currently what matters. So let's deploy this. It will take a bit of time to deploy. You can just press review and create, and then it will give me this. So let's just press create. This takes about 5 minutes to deploy. For that time, let's explain the code to you. This is a workflow. OK. Now what this workflow does, it basically is working on pushing something to the master branch. Don't worry. Pushing means basically I'm telling my GitHub. GitHub is a place where I can store code, of course. I'm telling my GitHub that, hey, this part that I have written, I want that to be here. Okay. So you can see I'm setting up the Python version, I'm setting up the GitHub actions, etc., etc. Right. So the deployment is in progress and the deployment is complete. Okay. So I'll just go to resource. And here, once you have this, you can see my URL name, now let's go back once. Let's go back once. You can see this name. This name is not what I set. This is a random name. Now this name is something that Microsoft creates themselves uniquely. This name is not given to us. This name they are creating uniquely, but this does not affect on how I've made my web app or the name of my web app. So let's go to resource. Name of the resource is Azure Fundamentals 2762. And with this, we'll go to deployment center. OK, in deployment center, we can basically deploy anything that we want. Right. So I have already connected my GitHub. OK, so if you don't have your GitHub connected, you can just there'll be an option to select GitHub. You can just create your GitHub account and put your code there and then select GitHub. It will open up a pop-up and then it will just ask authorize or not. If you authorize, then your Microsoft Azure will get the access to your GitHub, right? It will get access to your GitHub and then it will take the code from your GitHub. Now it will tell to select my organization. Now, since I don't work in an organization, my organization will be my name itself. That is my original name for my repository, not my repository, my account name. OK, now my repository will be the diabetes predictor. And my diabetes predictor, I have two branches. One is my master branch, and this branch I just created for example, so that I can show you that if I have multiple branches, I can have things like this. Now, what is a branch? If you think of a tree, now suppose one branch of the tree is holding flowers and one branch of the tree is holding fruits, right? Simply. In the same way in GitHub, uh, I can have a master branch that is my main branch that will hold all the other branches. And I can have other branches which will hold different things. The same thing happens with code. OK, so since I have a workflow here already, so that is why it is giving me the option of add a workflow. OK, but it doesn't matter if you don't have one. It will tell you that create a workflow. OK, this option might not be there for you. It will just tell that create a workflow. Now, once you have done this, I suggest just recheck if everything's OK. You have selected the right repository and the branch. After doing this, just press save. Now, as you saw, I didn't have to care about anything, how it is going to deploy, what is going to get installed. I don't have to care about. Only thing I have to care about is that, OK, I have this system. I have this system and I have a requirements.txt. I have my app. My Azure is going to detect everything for itself. OK. Now this has started deploying. Now you might see there is no changes in this page, but that doesn't mean that this is not running. You see, this is a graph which shows me how much activity is there. You see, I already have some activity. OK, this is the activity I have. All of this time it was just flat. Now I have activity. Where is the activity? You can go and see it in GitHub Actions. So as you can see, there is my Azure App Service built. As I told you, what is App Service? Let's go back to my PPT. See if I can find App Service. OK, yeah, right here. App Service. It's under Compute Services. So what is App Service? It is a PaaS solution. Sorry for that. It is a PaaS solution, and we have PaaS here. In PaaS, we have App Service, and that App Service is exactly what we are deploying right now. OK, now let's go back to the slide I was in, or I'll get lost. So this is deploying to production. Now it might take a bit of time. You can see that where it is working and stuff. So this might take a bit of time, but it doesn't matter. As you can see, I've tried this multiple times and this is how it works every time. OK. So one big thing that I want to tell you here is look in the GitHub workflow. In the GitHub workflow, I told you that there is on push. I told you about triggers, right? This is known as a GitHub workflow. I told you about workflows. There are triggers, right? That trigger the workflow, right? This is a push workflow. So whenever I push something, I tell my GitHub that, OK, this code is something I want. This code, I want this code to be on there. OK, so what happens? It tells me that on pushing my code, this workflow will start. Now, what are the steps of the workflow? Every dash that you see here, every dash is basically a step. So you can see what is the name of the step? Setting up Python version. Second step, create and start virtual environment. Third step, install dependencies. In install dependencies, you can see we are what file we are running? We are running requirements.txt. It is exactly the requirements.txt that we had right here. OK. These are the files that are running. So let's go back there and the rest of the thing I'll explain. So after installing, we are just uploading the artifacts for deployment job. This is something that Azure does itself. You don't have to worry. OK, so what I'm going to deploy on now, you can see I didn't do anything of this myself. Azure automatically saw that, OK, best place for deploying this will be this. So I'm deploying it on where am I deploying it on? Ubuntu latest. In which system? Production. Now you can, I'll show you what is production. As you can see, we under environments, I have production and this is in progress because I've already deployed something, right? So I told you this will take a bit of time to deploy. These usually takes around 4 minutes, sometimes even 9 minutes, right? So this is how you can basically deploy something if you want. I'm not really sure. It'll take a long time to deploy. If I refresh this, let's see if I get something new. But as of now, it is not deployed. But if I go to this website, then let's see what happens. It will tell me that your app service is set up, right? Your app service is set up, but your deployment is not ready. OK. So while this is getting deployed, let's see the roadmap to the Azer 900. Okay. Here I'll tell you how to pass the Azer 900. Very important. I've already been telling you the important questions and the regions where the questions might come from. But the Azure Fundamentals exam is something that every cloud enthusiast should take. I strongly believe in that. And if you're interested about Azure and you want to make a career in cloud, then I would suggest you to take this as your first exam if you're going about Azure. So as I said, this cloud concepts that we have, the basic cloud concepts that I told you about in the first slides will have 20 to 25%. Very important. This is the highest among any of these. OK. So these first few slides I told you about, right? The types of cloud, the cloud services, the shared responsibility model. Sorry for not telling you, this is known as the shared responsibility model, right? It tells us what are we responsible for and what the cloud is responsible for. The ones in the blue are the ones that the cloud is responsible for, and the ones in the green are the ones that we are responsible for. OK. After that, the Azure features, the Azure services, these are very important. And these are basically the ones which are included in this. OK, and the core Azure services that I told you about, that is basically this. Let's see this one, this slide, all these things under compute, networking and storage. A lot of questions come from here and this is containing, I think, 15 to 20%. So if you do this, you're kind of already doing 35 to 45% is complete for you, right? Other than that, I seriously suggest going for the second last module, that is identity governance, privacy and compliance. These four things, this also gives us 15 to 20%. So mix that with this 60%, approximately 60% is already done. Minimum of 50 and a maximum of 65% is already done for me. Rest of the things, core solution and management tools. These have a bit of the influence of the things like I told you about uh, the IoT and the ML services. Those are kind of the core solutions and management tools we can have. So it kind of comes in here, but there are more. OK, so you might ask me, if I am not studying everything right now, then where will I get the resources? Well, you will get the resources here. This is Microsoft Docs, and here you will basically get everything. I studied from here. I scored, I think, an 839 out of 1000. So in this website, this is basically Microsoft's official website where you can go and learn the course and learn about Azure. You can also watch the free code camp course. It's present on YouTube. It's a 3 hour or 4 hour course, 3 or 4 hour maybe. This is very good for um, this is very good after studying this. I suggest studying this first. So where can you find it? Just go search is at 900. First link, the very first link is the exam is at 900. So you will see it will tell you to schedule the exam. But when you scroll down, you have the learning paths. What do you have to do? You have all these paths that you can explore, right? These are made to make you understand the things in the most basic way and the best way possible. Okay. So, okay. So about my app, let's see if it's still deploying. It's still deploying actually. So I'm not really sure how much time this is going to take. So as you can see that my activity has gone up by a lot since I'm deploying my app, right? Let's see if I can see what it is deploying. I cannot really see. But whatever, in some time it will show that it has deployed, and with that we can just take for granted that your app is going to deploy. If it doesn't deploy, then some things I'm going to tell a way how to check it. First, check the workflow. What is giving it a problem? OK, check the workflow first. Very important. Next, check your requirements. This is an extremely important part for me. If you want me to show you, I have had so many bad deployments. It is not really present here, but it was in the second one. I've had so many failed deployments just because of the fact that my requirements.txt wasn't working properly. This file is very important, and the things that you put into this file, Azure is automatically going to read and install those. OK, so don't give any spaces or stuff. These are the version numbers. And after doing everything, then check your code. OK, I always suggest having a local server where you run the code. If you want, I can even give you the link of this code. So let's send you the link. Chat box. OK, so there you can go and just check the link, how it is working and how it is not. So with that, I think we are pretty much done with our stuff. If you have any questions, then I am allowing you to unmute and you can just ask me whatever you want. Give me one moment here. Oh, sorry. OK, any questions? No questions. OK, so how did you think? How was the session? If you want, you can just give me some sort of a like, thumbs up, heart, whatever. And somebody is raising a hand. Do you want to know something? Something I can help you with? maybe deployment, maybe one of the sessions, maybe one of the regions where I can help you with.
Hello, Mr. Sabyasachi.
Hello.
Yeah, good evening.
Yeah, what is your question?
Yeah, if you don't mind, would you share us the material that you have displayed on the during the meeting?
This presentation.
Yeah.
Yeah, I'll share it. Don't worry. So you registered with the mail, right? I'll send it to the mail only.
Yeah.
Don't worry.
Okay. Yeah, that's all.
Okay, thank you.
Apart from that, the session was very nice. You explained it in a much better way than others. That's what I can say. Thank you.
Okay, thanks a lot. Okay, so I think with this, we will end the session. And if you have any questions so far, as I said, my contact is sabyasachi.seal@studentambassadors.com. You can also reach me at iam.sabyasachi.seal, basically this word again, @ gmail.com. Okay. So if anything you want to ask me or want to know, you can just ask me. Until then, thank you for joining, and you'll get your certificates about 2 or 3 days from now. So that was it. Thank you. Sorry, one moment. I have to stop recording, right?